Hi, today I would like to present how to make use of your private locations history data collected by your Google or Android phones. As you might know, if you opted into your phone collecting your GPS data, Google stores all of your locations history on their servers. I thought that if they possess our data, we might as well get it and make use of it ourselves. And today's video is going to be all about how to get the data, parse it, and make it readable and usable for us. Our phones are collecting our GPS data in great accuracy in terms of seconds and meters. I'm not going to bother with the question of whether or not opting into this service is a good idea. I would just assume that if you opted in, you have a reason and this service has value for you. This data is available for the users through the Google Maps Your Timeline interface. However, this interface offers very specific functionality. Through the interface, we can only see where we were on a specific date. We cannot perform basic analytics or reverse queries, such as when was I in Paris, or how many times have I been to Paris, to France, or Paris. Furthermore, we are dependent on Google making this application available for us, and if it stops, our data might be lost forever. The data is available for download through the following link in a JSON format. One of the things that I would like to achieve with this exercise is to get a reverse querying to what Google actually allows you to do. At the moment, Google just gives you a place to select a specific date and it will show you what you've done on the specific date. But what about if I want to select a specific location and see where I was when I was in this location? In this case, you can see I'm looking at Champs-Élysées of Paris, and I can see exactly when I was in this case in October 4 at a specific time. It took me about 20 something minutes to walk through the street, so you can see the exact addresses, the exact timestamp, and what I was actually doing. Same thing I can do it for Broadway, New York. It's a totally different time. This was in 2012, 16th of September, and you can see at which part of the street I was still and when I was walking. Let's describe the challenges of making use of this data. First, the data comes in a single big JSON file. Mine was around 300 megabytes. A typical Notepad++ might not even be able to open this file. And since it is in JSON format, it is not simple to parse or split the file. Second, the data is not readable for humans. Timestamps are in epoch format and the coordinates are missing the decimal points. And even then, we will need to convert the coordinates to actual addresses. This could be done using the Google REST API or other vendors, which return an address JSON for a given pair of coordinates. However, this API is limited to 2,500 free calls per day, when in fact my file, for example, contains 1 million records. So without any logic, it will take over a year to get all of the addresses back. Here you can see a sample from the JSON file that describes a single location record. We would want to be able to parse so that the epoch timestamp will be converted into a date. In this case, 17th of August 2013, 8 AM. The coordinates to an actual address, in this case in Paris, France, and choose the most likely activity. Still means that I was not walking or in a vehicle at that time. I used the following tools to create the process. I built the jobs in Talend Studio version 6.4, although almost every earlier or later version will probably do. To split the JSON file, I used the Talend Data Mapper, which is a feature that is part of the Talend License Studio. However, it will be possible to create all of the functionality in Talend Open Studio, which is free. I used the local MySQL database to store the results. Of course, you can choose any other DB as you wish. I decided to create 4 jobs to complete the process. These jobs will be made available on my GitHub account as Talend jobs. Let's go into the process step by step. The first job I created, the purpose of it is to take the large JSON file, 300 megabyte, and to split it, first of all to parse it into a CSV, a flat format, and then to split it into chunks. The reason I chose to split it into chunks is because I prefer to working with many small files instead of just one big file. The way I do it is I use the Talend data mapper, which can give me a mapping easily with a wizard between the format of the JSON of Google and the flat format which I created. If you use the Talend data mapper, which is here at the hierarchical mapper part of the studio, it's quite easy to get this functionality done. However, there is also the possibility when you use the OpenStudio to create this as a normal file JSON, and then in that case you will use a JSON component to read it, and not this THMap component which I'm using here. The difference between the JSON component and the THMap component, which can only be found in the licensed version of Talend, and this component, the tJSON input component, which can basically provide, in this case, the same functionality, is that with the JSON component, it took a lot longer to read the JSON file, and I had difficulties parsing all 300 megabytes at once. I needed to split the files, while with the THMap, which you can see here, I was able to parse the entire files in less than a minute. Now, in both cases, it's very easy to retrieve the schema, whether if you do it here in the file JSON part of the metadata or the hierarchical mapper part of the data. You just need to follow the wizard. The schema is retrieved automatically. I did not need to make any modification. And on the left side, on the right side, you have the CSV to map to. So you can do it with both functionalities, either with the JSON component or with the HMap component. And finally, after I got this CSV on the other side as one file, I wanted to parse it into multiple files, and in this case you can see you can do it in the advanced settings of the tfile output delimited component by just mentioning how many records per file do you want to have. After the first job, I'm supposed to get as a result many flat files with this structure. First the epoch time, then a pair of coordinates, and then just the type of GPS record, for example, exiting a vehicle unknown on foot or something like that, and so accuracy and so on. So I can later use it for however I want to parse it. The second job handles most of the logic and has two flows. The first objective is to load all timestamps to a DB table with a mapping to normalized coordinates. The transformation of the coordinates is for two reasons. The first is to place the decimal points at the right place. Without that, the API would not return any results. I'm also replacing the last two digits of the coordinates with a constant. I chose 50. The reason for this is that I found that the last two digits do not make a difference in the actual address returned. And since we are limited in API calls, I'm trying to do everything I can to reduce the number of calls I will make to the API. The job starts by iterating on the files created by the previous job. Then we replicate the flow into two subjobs. The upper one responsibility, as I said, is to write the data into the database, only the time steps and the coordinates. And before we do that, we have to do some transformations. All of the transformations are done here inside the tmap. I've created some Java routines. First of all, to replace epoch time by actual date. So when it comes out, it becomes an actual date. And I created another routine to make the logic I mentioned regarding the decimal point and the normalization of the coordinates. Furthermore, I'm doing some filtering on specific types and confidence that is coming from the records, because I don't need to actually use all of the coordinates when, for example, when the type is unknown or the type is tilting. I'm not interested in this data, and of course you are free here to add your own logic to the process. The resulted table looks like this. On the left side we had the original coordinates, and on the right side you have the normalized coordinates, and also here you can see the actual timestamp instead of the epoch time. Furthermore, I chose to keep the type of the GPS and the confidence because I will maybe use it later for refining my queries when I use the data. The second part of the job is all about getting unique coordinates that will later be used to query the API. The only logic that I do here is filter some of the unwanted coordinates. Of course, this is a matter of your consideration. For me, I thought that I'm a little bit less interested in anything that was under the accuracy of 50, and for example activities like in vehicle, maybe you would like to remove altogether because you will get a lot of coordinates that are places you have not actually been in but just drove through. This job simply results in a long list of files. The files are just, as you see on the right side, pure pair of coordinates. Here they are not yet normalized. The reason I chose to add the epoch time to the files is if I want to prioritize what I query first, because as you know, as we said, we cannot query all of these coordinates to get the addresses on the same day, and we will have to decide what to do earlier and maybe what to do later. So that's what I wanted to differentiate between the input files for later. The third job is all about actually making the REST calls to the Google Address API. I'm starting by reading all of the coordinates from the different files I saved. I'm going to normalize the coordinates to, as I said before, limit the number of calls that I'm going to make, so disregarding the last 2 digits, making a unique, so nothing will come twice, and I'm also caching everything that I already queried in a file, so I would never query anything twice, and this is achieved here in the tmap by using the catch lookup inner join rejects. So only things that I've not actually queried before will come out of this, and then I make the actual calls. You will need your own token for the API, and as I said, your own personal token. If you don't pay anything, it will be limited for 2,500 calls per day by Google. Then I make sure that I have a result, because after 2,500 calls I'm going to get an empty result. The empty result is not going to be more than 9 rows. So that's the trade-off that I found. So if I have more than 9 rows, I will log this successfully and continue, and if I don't have more than 9 rows, I will delete. So in this case, when the API calls will start returning its empty results, I will just know that I'm not going to cache the results anymore. I would like to just take another moment to emphasize how important the normalization is. As you can see from a specific file here, I read 4,500 already unique pairs of coordinates. However, after I normalize and get rid of the last 2 digits and I try to get the unique count again, I get only 1,700. So it's less than a half that I removed in this case, and I saved many calls, and again also saved many calls by not repeating any query again. Each API call returns a JSON file with this structure. Again, this is a new structure only for the address for a specific coordinate pair, and we will deal with it in the next job and final one. In the last job, I'm reading the JSON results. I'm using the normal JSON components in Talend, and as you can see, I have already the schema here. The schema is created automatically by the wizard. So again, if you do not know how to do that, just simply go to metadata, go to JSON files, and create a new JSON file and just point to a sample file. This will create a schema for you. You have to point it out to a flat schema that you want to create. In my case, the flat schema is just the three strings here: long name, type, and formatted address. And I load this to a new table which is called Google Addresses. You can see that I also join it to the original coordinates in order to be able to join to the other table. After I ran all 4 jobs, I basically created 2 tables, one with the coordinates and the timestamp, and another one with the address and the coordinates. I'm able to join the 2 by just joining on the coordinates, and I can have all the flexibility that I wanted to achieve. I can basically have reverse queries or do analytics. This is what I set up to do, and now I have full flexibility with the data. I just had to give up some of the records where it was not too accurate and where it was redundant, and so I achieved what I set out to do. I hope you enjoyed and found this useful, and I'll see you in the future in other videos. Thank you.